Hi students, this is Dr. Penrod, and this is your audio PowerPoint for chapters 7 and 8, which deals, both these chapters deal with the immune system, adaptive immunity and alterations in immunity. And then also I'm adding in some information in this PowerPoint that may not be in chapters 7 and 8. It may reach into another chapter that's in the Pathophys book, chapter 6, but you will, if you study what's on this PowerPoint, chapters 7 and 8, and you also, anything additional that I add into the PowerPoint, then you will be fine as far as studying for the test, and you'll have a good overall understanding of the immune system. So I'm going to go ahead and get started. One thing that when I taught this last semester, something that helped me and the students is sometimes if you read if you're studying about a topic and you're having a hard time understanding it in the pathophysiology book, I would bounce back to the IGGI book that you have for MedSurg, because sometimes the IGGI book may explain things in a little more at more of a basic level than I found with this Pathophys book. So it will help you a lot if you bounce back and forth. There are some concepts that you'll be able to understand with the Pathophys book, but this book really is, it goes into a lot more depth than what you need to really know as an entry-level nurse, or even taking NCLEX for that matter. So my job is to screen the information that's in the Pathophys book and bring it to a level that you understand. And I have a dual role. I have a role of helping you prepare for your exams and helping you take the HESI Pathophys exam at the end of the semester. So I have that goal also, and then also to get you ready for NCLEX. So between helping with the exam, helping with HESI, or helping with NCLEX, those are my main objectives with this course. And I really do want to apologize because I am a little hoarse today. So I know this is going to be hard for you to follow along because I don't sound really great. But we will do our best here. So chapters 7 and 8, and then additional information that I'm adding in for immunity and alterations in immunity. Okay, so we're going to get moving. Okay, this is a preview, and this is just explaining immunity and inflammation. This might be information that might have come from chapter 6. But anyway, immunity and inflammation. So the purpose of inflammation and immunity is to meet our human need for protection by neutralizing any threats to our environment, eliminating that threat, or destroying that threat. So when their immune system is working well and they are healthy, then they are immunocompetent, or they have immunocompetence. So we do have lines of defense for our immunity. We do have, our bodies are structured in such a way that we do have physical and biochemical barriers to infection. So inflammation is one of those. Okay. Well, let me back up. So our first line of defense is our physical biochemical barriers. Our skin very much is a line of defense. And our second line of defense is the inflammatory process. And then the third line of defense is adaptive immunity. And we'll talk about that in more depth. So there's two different types of adaptive immunity. There's antibody-mediated immunity. That's when our body forms antibodies to fight infection. And then we have cell-mediated immunity, where there are different cells in our bodies that help help produce immunity. So we will talk about all of these. So number one, our physical biochemical barriers. So our skin, the lining of our stomach, our GU tract, our respiratory tract, they all have different structures that help resist invasion. So like our respiratory tract, we have if you remember from your anatomy and physiology, we have the cilia that, and the goblet cells of the respiratory tract that help produce mucus, help trap foreign particles, and help us expel those, foreign particles through coughing and sneezing. So, the low temperature of our skin, the low pH of our stomachs, different enzymes and peptides that we have within our bodies that help facilitate the breakdown or removal of pathogens. And then we have our normal flora. So, and I think this is an area that it's really become more and more, I think that the healthcare community has discovered more and more the role of normal flora for us in fighting infection. So our normal flora, it is a defense system without altering our body negatively, and a normal flora helps perform several functions that help assist with immunity. So number two, our second line of immunity is inflammation. And inflammation, it is a good thing to a certain point, because what it does is it walls off that area to further tissue injury or any further invasion by foreign proteins. So it's a very immediate response, as I'm sure some of you guys are aware. If you ever have an injury somewhere, you have that inflammation that kicks in. It's an immediate protection against the effects of tissue injury and invasion. It's short term. Inflammation does not produce immunity. This is just our body's natural response. It's like our second line of defense. So the degree of inflammation, it really depends on the intensity, the severity, the duration of exposure of that foreign protein that's stimulating the response. So I'll look and see if the next slide goes into the sequence of the inflammatory response. But the purpose of inflammation, like I said, is the walling off of that area against further injury, against foreign particles, but also inflammation helps trigger the body's response, the antibody and the cell-mediated response. And, just bear in mind, inflammation, you guys know, happens with or without infection. All right, so it doesn't look like I'm going to go into any more depth about the cell types. Well, I might eventually. First of all, let's look at neutrophils. So neutrophils are actually, they're used in phagocytosis to destroy invasions. Neutrophils respond to inflammation, and there are different types of neutrophils called segs or polys, segmented neutrophils, polymorphonuclear cells, and then also bands. So all of these different subtypes of neutrophils, when we look at a lab value that has a white blood cell count, we'll see a level of segmented, polymorphonuclear, and bands. And when you're in the hospital, you might hear the nurse say that this patient has a left shift or a shift to the left. And what that means is they're looking at all those white blood cells, and if they see the immature white blood cells rising up, if they're starting to see that all of these different types are rising up in number, even though the overall white blood cell count may not be elevated, we might see these subcategories start to become elevated, and that means that our patient is mounting some type of immune response or inflammatory response. Okay, in neutrophils, they respond to infection, stress, medications, and also necrosis without, in the body. Macrophages are also, they destroy invasion by a process called phagocytosis. They also respond to inflammation. They actually stimulate antibody-mediated immunity and cell-mediated immunity. And macrophages actually stimulate bone marrow to send mature white blood cells to the area of concern. And then we go to basophils. Basophils actually release chemicals that trigger inflammation, and they also assist the neutrophils and the macrophages. So basophils respond to different chemicals in the bloodstream. So basophils respond to heparin, histamine, serotonin, different kinins, and leukotrienes. And when you see an elevated basophil count, you'll see that in response to a patient who has allergies, patients who have anaphylaxis. And anaphylaxis is when you're in a respiratory emergency where you cannot breathe. Asthma situations will elevate basophils, as well as a disorder called Crohn's disease. And you'll learn more about Crohn's later on when you get into the GI system in MedSurg. And then the last cell type that's involved in inflammation are the eosinophils. And the eosinophils, they release chemicals that trigger inflammation, and they also assist the neutrophils and the macrophages. And the eosinophils actually can limit the inflammatory response. So these cells are released in response as in situations where inflammation needs to back off. So it's kind of interesting. And as you progress through pathophysiology, this is a phenomenon that you're going to see very often, that the body has one function where they produce a response, and then also our bodies are structured in such a way that we have a response, triggers a response that inhibits the first response. So it's like a shutoff valve. So the eosinophils are released, and they actually can start tapering off the inflammatory response when they're released. So our bodies just have this natural mechanism by which we turn on the switch, and then we help turn off the switch, whatever we're talking about. And you'll see that theme throughout the time that we're throughout the time that you're in pathophys. Okay, yeah, here it is, the sequence of inflammatory response. I thought it might be coming up. So stage 1 is the vascular stage where, and just think about to yourself, anytime you've had inflammation, like let's say, well gosh, I've been working out lately, so my knees really I'm having a hard time, and I think that maybe I pushed a little too hard last week, and I've had some inflammation in my right knee, and I can tell that. So I was in the vascular stage where I had warmth, redness, swelling, because I've produced some kind of stress to my right knee. So these are the symptoms. Warmth, redness, swelling, pain, decreased function. Okay, so the stage 2, the second stage is when the neutrophils increase, and they help try to remove dead white blood cells to the area, eating necrotic tissue from damaged cells, and they attack and destroy organisms and remove that tissue by that process called phagocytosis. And then we have stage 3, which is when we have tissue repair and replacement, where the white blood cells trigger new blood vessel growth, scar tissue forms, and sometimes the patient may have some loss of function at that point to that area. Okay. All right, so like I said, the overview of function, the purpose of inflammation in immunity is to neutralize, eliminate, and destroy organisms. Our body has this natural mechanism where we have our own cellular fingerprint, where we recognize self versus non-self. So when we have a some foreign organism, like let's say bacteria, like let's say, we could use an example of like a staph infection. Okay, so let's say you get a cut on your arm, and Staph aureus enters into that cut. Okay, so your body sees Staph aureus and determines it's non-self. It's not part of your normal, cellular, any cells within your body. So it recognizes itself. It recognizes the Staph aureus as non-self. So then that's what triggers the inflammatory process and the immune response. That recognition of self versus non-self. We have this cellular fingerprint. It's called HLA, or human leukocyte antigens. They act as an antigen if inside another person's body. So they're proteins that there are proteins on that HLA complex that either recognize that whatever cell it's come in contact with is part of the host, the body of the host, or if it's something different. So the immune system cells compare the surface HLAs to determine this. If it's human, if it's my HLA and my HLA, there's no problem. But if it's something foreign like Staph aureus, then the immune system will kick in and work to eliminate it. Okay, so just know that we have this mechanism. You probably already know this already. And this is actually a picture of a protein with the HLA antigens on it. And the way they've illustrated this is it's our unique barcode to us. Okay, there are different receptors on the cell, but the HLA is what we're concerned with the immune system. And here again, here's a diagram that explains what I'm talking about. So we have our immune system cell. It recognizes self cells, but it will fight against and attempt to destroy something, a cell that it deems as non-self. Okay, like I said, HLAs, or human leukocyte antigens, are universal. They are unique to you, and they actually determine the tissue type of a person. So, I just mentioned this. I just went through the slide. And this is how our immune system is formed. So we have bone marrow, and we have lymphoid stem cell that comes from the bone marrow. And that stem cell, it develops as in the thymus or in the bone marrow to produce immune system cells. So if that stem cell is sent to the thymus will start developing it as a type of cell for immunity called T cells. And if these lymphoid stem cells are produced in the bone marrow, they will they will develop into B cells. So this is where we have our T cells and our B cells that are used for cellular immunity. Okay, so just know that. T cells are formed in the thymus from stem cells from bone marrow, and B cells are formed from bone marrow. That's been these stem cells that are released from the bone marrow and then goes ahead and produces the B cells. And we'll talk about B cells and T cells in just a little bit. This is part of our cellular immunity or humoral. Well, humoral immunity is actually antibody-mediated immunity. So, we'll talk about all of these different types in just a little bit. Okay, so let's talk about antibody-mediated immunity first. So this is when we have an antigen-antibody interaction. Antibody-mediated immunity is also called humoral immunity, just like the previous slide showed. So it's when antibodies are produced by B lymphocytes. So I'm actually going to see if I can go back. Okay, so this is what we're talking about right now. So the B cells that are produced in the bone marrow help trigger antibody-mediated immunity. All right. So there are 7 steps to antigen-antibody interaction. You don't need to memorize these, but just kind of know, in essence, what happens in antibody-mediated immunity. So we have exposure of the antigen, large numbers that overwhelms the inflammatory response. We have recognition where the B cell recognizes that antigen as non-self. So then the macrophages, they physically attach themselves to the antigen and they expose that antigen's recognition sites. So then the lymphocytes, they sensitize, they go through lymphocyte sensitization, where the B cell recognizes the antigen as non-self and is sensitized. And when it becomes sensitized, it will recognize that antigen in the future. So at this point, the B cells divide and form plasma cells and memory cells. Plasma cells produce antibodies against that antigen, and memory cells are produced, and these are sensitized, and they function when the person is exposed again. So this is all part of how the antigen is recognized. The B cells are sensitized. The antigen they recognize the antigen for the future. And in particular, the plasma cells, they start producing the antibodies, and then the memory cells, they're produced for that antigen, and they will react if the person is exposed again. And then the 4th phase is antibody production and release. It's when the plasma cells start making, I have in my notes over 300 molecules of antibodies specific to that one antigen. And these plasma cells, these molecules that are created, these molecules of antibody-specific cells, they will remain in the bloodstream from 3 to 30 days. The next stage is antibody-antigen binding. So the antibodies all bind together with the antigen, and they form these Y-shaped molecules. They actually form quite large molecules when they bind to the antigen. And then we have agglutination, lysis, complement activation, fixation, precipitation, and inactivation. And all of these are what the antibody does to the antigen. So they start destroying the cell membrane of the antigen, drill holes in it. They remove and destroy the antigen from the bloodstream. through IgG and IgM, and then the molecules that are formed from this binding with the antigen, they become easily removed by the neutrophils and macrophages. So the neutrophils and the macrophages, they actually aid in like the cleanup of the dead particles from the antibody-mediated immunity. And then lastly, we've got inactivation, where the antigen basically is rendered harmless and the patient develops sustained immunity. Okay. Here are these large complexes that I was talking about. So antibody-mediated immunity forms these Y molecules where the antibody attaches to the antigen. And actually, they form these large ones that help carry the antigen out of the bloodstream. So different classifications of antibodies. We may have immunoglobulin, which is the same as an antibody, and we have IgM that's actually made first in antibody-mediated immunity, and IgG that's made after re-exposure to that antigen. So these are the two main classifications we have. So IgG that's made after re-exposure, it actually has the most protective activity for the patient against that antigen again. Now let's switch to cell-mediated immunity, okay? So if you went back to that slide a couple slides ago where it had the diagram, now we're looking at the T cells. The T cells are responsible for cell-mediated immunity. They're formed from the thymus, and there are different types of T cells that help produce what's called cell-mediated immunity. This is cell-mediated immunity is important in preventing the development of cancer, and it does help with that, and metastasis after exposure to carcinogens. So, like I said earlier, our body does have natural mechanisms by which we fight infection and fight foreign invasion and abnormal cells that develop, such as in cancer. So that's another kind of like side benefit to cell-mediated immunity. So let's look at these different types of T cells. So we have helper or inducer T cells, and these cells, they easily recognize the self cells versus non-self, and they secrete lymphokines that help increase the activity of other white blood cells. So they help the other cells to do what they need to do. So the helper inducer T cells, they increase bone marrow production of stem cells. They help facilitate stem cells maturing in the thymus, and they cause squads of white blood cells that causes inflammation, antibody activity, and cellular protective actions. So those are all the roles of the helper inducer T cells. Then we have the suppressor T cells, and these help prevent hypersensitivity. So if our bodies were just made of helper inducer T cells, then we would have a reaction, inflammatory or immune reaction, all the time. So we have to have the suppressor T cells that help prevent an over amount of response to the antigen. So suppressor T cells prevent the formation of antibodies that attack normal healthy self cells. They secrete lymphokines that help inhibit cellular growth and activation, and they are responsible. They will, like I mentioned, we have to have this natural balance of helper T cells and suppressor T cells, and typically it's a ratio of 2 to 1. patients who do not have suppressor T cells, they are people who have seasonal allergies. So I have seasonal allergies, so my suppressor T cell function is not as good as what it could be, because I have this, hypersensitivity response. And then we have T cells that are cytotoxic, cytolytic, and these T cells, they destroy cells that contain the processed antigens, in particular parasites, have this complex of MHC, or major histocompatibility complex. So these T cells, they attempt to destroy cells that contain these particular antigens. They also identify a self cell infected with a parasite and will bind to it. And then also they will deliver a lethal hit by drilling holes into the antigen and cause death. So cytotoxic, cytolytic T cells do that. And then I just mentioned memory cells. Well, no, those are different. And then we have memory T cells that produce memory for when the person is exposed to that antigen again. And natural killer cells that have direct effects on non-self cells. And natural killer cells help destroy unhealthy and abnormal cells that are our cells, our self cells. And then lastly, cytokines. Cytokines is a term for hormones that are produced by white blood cells and tissues, that they tell specific cells how and when to respond. They control inflammation and immune response. And different examples of cytokines are interleukin, interferon, colony-stimulating factors, and tumor necrosis factor. Okay. And I think I'm going to stop this PowerPoint, and then I'm going to make a different one for Chapter 8. So be looking for a separate PowerPoint for Chapter 8 here.